Hello, my name is Øystein, and welcome to this lecture on basic concepts in statistics. These are the subjects we'll discuss in this video, and yeah, so first I'll talk about random samples and types of variables. Then I'll move on to measures of central tendencies, like the mean, and dispersion measures like the variance. And finally, I'll draw a box plot to, to visualize what we've been through. Okay, so first we will talk about random samples. And a random sample is a subset of a population where the subjects are selected at random. In other words, all people in the population are equally likely to be part of the random sample. It doesn't matter if they have a phone or if they can't walk or anything like that. This ensures that all groups in the population have an equal chance of being in the sample. If you put up a poster at the hospital to recruit people to your study, the sample is not going to be random, or at least it's not going to be random if you want to sample from the full population in your city or your country. First of all, you only get people who volunteer actively, and that alone ruins the randomness. But you also will have too many nurses and medical students and too few carpenters and hairdressers. If the random sample is large enough, and it's truly random, then the proportion of all such groups in the random sample will be the same as in the population. For example, if 50% of the population you sample from have a university degree, you expect 50% of the people in your random sample to have a university degree. The same applies to ethnicity, gender, political ideology, socioeconomic background, diet, and so on. A perfect random sample has no systematic bias. Now, assume that the people in the circle constitute the population of interests. So it's not a very large population, and then we draw a sample. And does this sample look random? So these red circles are around people who are in the sample. The answer is no, because only males are selected. And we know that these guys are males because they have very little hair, as opposed to the females who have more hair. Okay, so however, this looks much better, right? So in this sample, we have 4 women and 4 men, and that's exactly what we expect if we draw people at random from this larger population, because there are as many men and women in the circle. Now, if we invite these people to participate in a study and all of the men reject participation, then the sample is not random after all, right? So if this study was on the effect of a drug, we cannot say anything certain about the effect on the men. And if the study was on political opinions, we only know about the political opinions of the women. So note that it doesn't really have to be have anything to do with their gender. So if these guys declined participation in the study, it doesn't have to be because they were men. It could be that they didn't want to participate because of something that's more common among men than among women. So some women could have also said no, but they just didn't choose to. These 4 women who were asked all said yes, and then some men could have said yes, but these men who were asked, they just happened to say no. Uh, and it still would be the same. So we don't know why they declined. We just can't say that they declined because they're men, but we can discover that men are underrepresented and women are overrepresented in the final sample. So that's why we know that the sample is not random. We don't necessarily know exactly why it's not random. Okay, so the point is that even if the randomization is perfect, something else may mess with the randomness so that the sample is not representative for the population. And one example of this is from the American election, not in 2016, but in 1948. So this is a very famous photo. It says Dewey defeats Truman, not Trump. But in fact, it was the opposite, where so Truman had defeated Dewey, and the headline gets it wrong. And this had to do with several factors, the reason why the headline got it wrong. But one of them was bad polling. So what most pollsters did back then was something called quota sampling. And that means that they asked lots of people for their opinions, and then they checked if the sample matched the population. And now, if there were too few men in the sample, they would ask more men. So if they had a sample of 1,000 individuals and they had 600 women and 400 men, they would go and get a hold of 200 men. The same with black people, for example. If there were too few or too many black people, they would ask more black people or more white people. And then they would end up with a sample that looked like a random sample based on the factors that they selected on. So if they, for example, had race and gender and income bracket or something like that, if that's what they selected on, they would end up with a sample that looks like a random sample across all these measures, but it's not actually a random sample. For example, maybe people who were likely to vote for Truman were harder to get in touch with. So maybe they worked longer hours or lived farther away from the pollsters. So that whenever the pollsters went out to ask people, a lot of the people who were going to vote were actually working, or they were at home far away. So they were difficult to get in touch with. And then the pollsters would ask a lot of people about their political opinions, who they were going to vote for, and they would answer frankly and be honest, and they would say Dewey because that's who they were going to vote for. Uh, but and then they would do the quota thing where they uh, got the right number of white people and black people and men and women, and they would end up getting the wrong result because their sample wasn't actually a random sample. Okay, so this that's all I had to say about random sampling and the dangers of random sampling. And let's move on to different types of variables. Okay, so there are four kinds of variables, or I prefer to use four kinds. There are many kinds of variables. So I would say that the main categories are nominal, ordinal, interval, and ratio. And nominal variables have no order or direction. For example, it's impossible to say which is larger of male and female, and the same applies to marital status. If we're comparing people who are married, divorced, single, cohabiting, widowed, or whatever, it's very difficult to set an order. Uh, if it's possible to set an order, we say that the variable is ordinal. Uh, if so, if the variable is categorical, but it's possible to set an order, it's ordinal. And so the distance between these categories is not necessarily evenly spaced. Regarding BMI, like we see here, we could use the categories underweight, normal weight, overweight, and obese. And we see that normal weight is less than obese, but we don't know how much less. We could be comparing somebody with a BMI of 18.5 with somebody with a BMI of 29.5, or we could be comparing people with one person with a 24.5 with a person with a BMI of 25.5. So we don't know the difference. We don't know how much the difference is. So we know it's more, but we don't know how much more. And for example, taking a mean in such a situation is not very meaningful. Okay, moving to interval variables, they have an order and the distance between categories is evenly spaced. So now we're getting somewhere interesting. Take, for example, temperature. 25 degrees is 5 degrees more than 20 degrees, and 20 degrees is 5 degrees more than 15 degrees. Now taking the mean is meaningful. The mean temperature on Earth, for example, is a number we hear about all the time, at least if we read the newspaper sometime. Still, taking ratios is not meaningful. So it doesn't make sense to say that 20 degrees is twice as hot as 10 degrees. And another example is birth year. So we can say that the year 2020 is 20 years after the year 2000, but we can't say that it's 1% later because year 0 is just, it's arbitrary. We just said, okay, let's say that 0 is this date and start from there. A final type of variable that we'll cover in this lecture is the ratio variable. And ratio variables are the same as interval variables, except that ratio variables have a natural zero. So height, weight, and income are all ratio variables because 0 meters, 0 kilograms, and 0 income actually means 0, right? So in this case, ratios are meaningful. For example, this guy is about 3 or 4 times as heavy and 40% taller than his wife. And we can measure this stuff, right? Because weight, 0 kilograms actually means 0, and 0 meters means 0. He's also probably about 100 times as rich as most of us. So that makes sense too with the money, right? You can have 0 money. If we measure temperature in Kelvin, then temperature also becomes a ratio variable. And we have that 20 Celsius is about 293 Kelvin, and 10 Celsius is about 283 Kelvin. So we see that 20 Celsius is not twice as hot as 10 Celsius, right? Because the difference is really between 293 and 283. So that's all I have about types of variables. So let's move on to the next subject, which is measures of central tendency and quartiles. So a central tendency is a way to summarize a data set with one number. It has to do with what we expect when if we draw if we get one observation from a sample, or if we have a lot of observations in a sample, what kind of observations do we expect to get? And the most common are the mean, the median, and the mode. So I will talk a bit about quartiles as well, although they measure something else, but we'll get back to that. Quartiles are related to the median, so that's why they end up here. But let's begin with the mean. Okay, so the mean is the sum of all observations divided by the number of observations. This is a useful measure when data is quite symmetric. It can be useful if data is skewed as well. It depends on what the research question is. Because it takes the value of all observations into account, it's also vulnerable to outliers. In the data on this side, we see that most observations are 10 or less, but the top four, so 20, 25, 53, and 72, pull the mean up to 13.8. Now, if we do not like that our measure of central tendency is so far from the center of the data, we can use the median instead. And the median is the observation that divides the data in two. So that's then we're ensured that at least our measure of central tendency is going to be in the center of the data. To find it, we order the variables and pick the middle one. It's very simple. And note that if the top four variables had been much larger in this situation, the median would still be 7. So it wouldn't matter if the largest had been 150. The median would still be 7. Because the median only cares that observations are above or below the middle. So in order to change the median, you would have to change the number 72 to something that's less than 7, right? Still, the median may not give much information about what the typical value in a sample is, which is where the mode is handy. So this is simply the most common observation in the data. In my experience, the mode is rarely used in medical research and health registry research. Okay, so the final subject in this section is quartiles. There are 3 quartiles and they divide the data in 4 equal parts. So note that the median is the second quartile. So that's why we we talk about that now. There are several definitions of the lower quartile and the upper quartile. So the first and the third. But I use this one. So Q1, the first quartile, is the median of the bottom half of the data. And if the number of observations is odd, we include Q2 in the bottom half. In this case, we have that there are 4 numbers below Q1, so 1, 1, 2, 2, and 4 numbers above, 4, 5, 6, and 7, because 7 is included. The third quartile, Q3, is calculated the same way, except for the top of the data. So we see that Q3 is 10, because there are 4 numbers below, 7, 7, 8, and 9, and 4 above, 20, 25, 53, and 72. So that's it for this section. And next, we'll continue with the dispersion measures.